For our second test, we want to see if men and women receive the same raises as was claimed. So we're back to our process flow now, open up our data. We go to the Analyze, ANOVA, t-test. We're doing a 2-sample t-test now because we've got a group of men and a group of women. In our data, raise is our analysis variable, the thing that we're measuring, and gender is the classification variable, the variable that determines which group we're in. We're testing to see whether men or women get larger raises than one another, so the null hypothesis is that they get equal raises. Our null hypothesis is 0 here, that the difference between them is 0. Okay, let's hit run. Performing our 2-sample t-test. In our first 2 rows, we see we've got 58 women and 72 men. The women on average received a raise of 7.3%. The men received a raise of 7.8%. So it looks like the women are receiving smaller raises than the men. But is this significant? To see if it's significant, we jump down here. We've actually got 2 different ways of doing this t-test, depending on whether we want to assume that the men and women have the same standard deviation or different standard deviations. If we assume they have the same standard deviation, then we'd be looking here at this equal variances t-test. If we assumed they had different standard deviations, we'd be looking at the unequal variances t-test. In either case, we're actually just over our 5% threshold here for the p-value. So in each case, whichever assumption we made about the variances, about the standard deviations, we would conclude we don't have evidence at the 5% level that the men and women earn different raises in their first year.